Hello, in this video, I'm going to go over some 3.4 written homework. So first one is antiderivative of 1 over 4x plus 1 to the cubic power dx. So in this case, we can just do the simple antiderivative. We need to use substitution. So now we need to determine our u. So I will let u equals to dx plus 1. Then I'm going to find the derivative of u at x. Then we got 4x plus 1, get derivative, which is equals to 4. Now we need to find dx, to solve for dx. So we know that du over dx equals to 4. Then we can solve x by multiply dx on both sides. I have du equals to 4 times dx. Then I divided by 4 on both sides. Now I solve for dx. dx is equal to du over 4. Now the next step is we're going to substitute dx and the u into our original function. So du is going to be replaced, 4x plus 1 is going to be replaced by u. Then dx is going to be replaced by du over 4. So now I have antiderivative of u to the third power du over 4. Now we can simplify it. So I can write it as, since it's 1 over 4 times du, so the constant, the coefficient, we can pull it out of the antiderivative, which gives me 1 times antiderivative of u to the third power at du. Now, I can write it as the exponential form. Now, that makes it easier for us to find the antiderivative. So now u to the negative 3 antiderivative is equals to negative 1/2 u to the second power, negative second power at du. Simplify everything. We have negative, no longer du, because we already done antiderivative. And we need to plus a constant term. Don't forget about that, because sometimes I do. 1 over, negative 1 over 8 u to the second power. And now we need to substitute u equals to 4x plus 1 into the original function. So I have a negative 8 times 4x plus 1 squared plus c. So that would be the final answer. Let me do another one. Number 2. We want to find the integral e to the 100 x power at dx. Now we need to determine what do we want it to be u. Because we know that the antiderivative e of x is going to equals to, the derivative of e of x is equal to e of x. So that means the antiderivative e of x dx is going to e of x. So it's easier if we can have the u equals to 100x, so that I have e to the u at du, which is equals to eu. So that's the idea behind that. So here I am going to let u equals to 100x. Next step is finding du dx. So, the derivative of 100x is going to equal to 100, and now we need to solve dx. So I'm going to skip in this step here, because I think this is, you can solve it. It's very similar to what we did earlier, the du over 4 equals to dx. So here we solve dx equals to du over 100. Now, we need to substitute this part for 100x, and then dx in here. So now we got integral of e to the u equals to du over 100. Simplify it. I got 1 over 100 antiderivative e of u at du. So after I simplify, I got eu plus the constant term. Now we need to solve for u because we need to substitute u back. So I got 1 over 100 e to the 100x plus c. Because our u is equals to, oh, I should use a blue pen. U is equals to 100x. Okay, next one. Shall we go over all of them? Let's do number, let me see, 4 or 5. Next do 4. Okay. Number 4, I have e to the 100 over x squared at dx. So now when we look at that, it looks like they have a lot of function. We have e to the some function power, and then we have x squared. So should we let u equals to 100 over x, or should we let u equals to x squared? You can try both. See which one you can solve it. Let's starting with the derivative of u equals to x squared, because the u substitution you have, especially when it comes to a complicated function, more complex function, they have a multiple way to solve it. It's not necessarily equal to certain things, but there must be some way it's easier than the other way. Let's try u equals to x squared. So I will have 100 10 over x over u at ds. Okay, that doesn't look like simplify anything, right? Because it still looks very complicated. As you can see in the previous example, after you substitute a u, everything immediately looks easier. So maybe we shouldn't let u equals to x squared. We should use u equals to 10 over x. Okay, so I got u equals to x squared. Okay, the x squared still look complicated. Maybe we should keep going. So du over dx is equal to 10x derivative. And then when we try to solve it, I got 10x negative 2 derivative, which is equals to, sorry, I copied it wrong. This should be negative 1. And now, when we simplify it, we should have negative 10 over x squared. Now, we need to solve dx, sorry. We need to multiply dx on both sides. So we have a du over, multiply dx on both sides. So du is equal to negative 10 over x squared times dx. So here's the trick to get rid of the fraction in here is by multiply the reciprocal. So the reciprocal is negative x squared over 10. So here we do the same thing, negative x squared over 10. So negative give you a positive. So we're done. So x squared, they cross cancel. 10 and 10 cross cancel. That's how we do it. When you see a fraction, multiply it reciprocal, which is the flip of the fraction. It will give you 1. All right. So our dx is going to equal to negative x squared over 10 times du. Wow, this is nice because you can see the x squared and the x squared in the denominator, they're going to cancel. So now let's substitute everything in here, especially the dx. So I have 10, oh not 10, e to the u. So I got e to the u over x squared. Dx is equal to negative x squared over 10 at du. So x squared cross cancel, and then we can pull the negative 1/10 out. So I have e integral eu at du. So our answer is going to be negative 1 over 10 eu at the constant term. Don't forget the constant term. Because when I checked your homework in last week, lots of students forgot about the constant term. I left you a comment to remind you that, hey, you forget about that. All right, and now we need to substitute du back into the original function. No, the u back, which is u is equal 1 over x. Okay, so that's it for number 4. Let's take a look for number 5. Number 5 is trying to find the antiderivative of square root of x plus 5 at dw. So this one is very obvious. If you have a square root, usually is everything under the square root is going to become the u. So we let u equals to w plus 5. So du, get the derivative of du is equal to 1. Then we solve a dw is equal to du over 1, which is equal to du. That one is easy. So now we substitute it into it. So we have square root of u at du. So first step, convert it to the exponential form and to du. And now we want to find the antiderivative, which is equals to 2/3 of u to the 3/2 du, because you want to add 1 and then times the reciprocal of the coefficient. Oh, we don't have du anymore because we already done the antiderivative. We just need to add the constant term. Now we substitute the u back. That's it. Number 6 is very similar to number 5. You just need to replace the u equals to whatever under the square root. So I'm going to skip number 6. I'm going to do number 7. Number 7 is you see a ln. Usually when you see a ln, which is the logarithm, usually that would be our u. Number 7 is integral of 1 over x ln of x dx. So we're going to let u equals to ln of x, and then find the derivative of u is equals to ln of x derivative, which is equal to 1 over x. Now we need to solve x. We can do the cross multiplication, which is, let's do some review here, algebra. A over b equals to x over y. So when you cross and multiply, they're still equal. So ay equals to bx. So we're doing the same trick. Du times x equals to dx times 1. So I got x times du equals to dx. Okay, so now we do the substitution part. So the integral of 1 over x times u dx is equal to x times du. Now, the denominator x and this x cross cancel. Now we have integral of u, 1 over u, sorry. Du. So this is going to equal to ln of u plus the constant term. So u we substitute back is ln of x. Okay, that's it. Plus the constant term. Don't forget about the constant term. All right, next one is number 8. Number 8, we have x minus 3 over x squared minus 6x plus 5 at dx. So in this case, how would you do it? Either let u equals to x minus 3, because this is a function, or let u equals to x squared minus 6x plus 5. You need to think about it, because we want to get the derivative of u, and which one would be more useful for us later, so that we can cancel either the x or the x squared, right? So if you get the derivative of the x squared, we will get x minus 6. So it would be more likely that we can cancel the x minus 3 later. If you just get the u derivative of x minus 3, you will end up to just get a 1. So it seems not that helpful. So that's why we are using u equals to x squared minus 6x plus 5. Okay, so here's the idea. I'm going to show you the step how I do that. All right, so our u is equals to x squared minus 6x plus 5. So du at dx equals to 2x minus 6. Okay, that still don't look like x minus 3, because we want to get rid of the x minus 3. But if you take a look, you might realize that, some of you might realize that, some of you might not. If I simplify it by pull out the common factor 2, we will end up to have 2 times dx minus 3, du over dx. Now we can solve dx is equals to du over 2 times x minus 3. Now we can substitute back to the integral. I have integral 3x minus 3 over u dx is equals to du over 2 times x minus 3. So now the x minus 3, they will cross cancel. Simplify, I have 1 over 2, 1 over u du. And the 1 over u is equals to ln when you get the antiderivative. So I have ln u plus the constant term, which is ln x squared minus 6x plus 5 at constant. That's it. Number 9 is similar to number 8. I'm going to skip it here. Now I want to do number 10. Number 10 is integral from 0 to 1 e to the 2x at dx. And I'm going to let u equals to 2x. So when we get the derivative, du at dx is equals to 2. Because we take derivative of 2x is equal to 2. So by now, lots of you might be able to do this very quick. If you don't, please practice more. So I have a du over 2. Now I substitute u and the dx back into the function. I have from 0 to 1 eu at 2 over dx. Dx over 2, sorry. Now, simplify it. I got 2 1/2 integral from 0 to 1 e to the u du, not dx. So after we get the antiderivative, This one is equals to e to the u from 0 to 1. This part, not including the 1/2. 1/2 should multiply all of your answer. So I have 1/2 e from 2x from 0 to 1. So everything we got 2 times 1 minus e to the 2 times 0. 2 times 1 is square, and then e to the 0 power is equal to 1. Because everything with the exponential power is 0 is going to equal to 1 for all the real number. Okay, so you can just leave the answer like that or simplify it by distribute the 1/2 into the parentheses. Either way. So number 11 is relatively easy. I'm going to skip that. I can give you the answer. For number 11, your final answer should be equals to 4. You can do the step by yourself. I want to do number 12. Number 12 is integral from 0 to 1 x square root of 1 minus x squared at dx. In this one, I will choose the substitution u equals to 1 minus x squared. And now get the derivative of du at dx is equal to negative 2x. Now we want to solve for dx. Then our dx is equal to negative du over 2x. Okay, so now we want to substitute this into the integral. We place the u and the dx. So what we got is from 0 to 1, I have x square root of u, and dx is equal to negative du over 2x. Now we can simplify it. The x cross cancel, and I want to pull out the negative 1/2. I got 0 from 1. U, square root of u, I want to write it as a exponential function. So I got u to the 1/2. So now when we find the antiderivative of u, integral of u to the 1/2 power is equals to negative 1/2 2/3 of u to the 3/2 u's power from 1 to 0. We can pull out the 2/3 out, so I have a 1/2 times 2/3 u 3/2 power from 0 to 1. Now I need to substitute 1 minus x squared back. Also simplify the coefficient. So I have negative 1/3. U is equal to 1 minus x squared, and then 3 to the 1/2 power from 1 to 0. Now we can calculate that. So the first is I have 1 minus 1 squared, and then 3/2, and then subtract 1 minus 0 squared 3/2. As you can see, sometimes I use cursive, sometimes I just use parentheses, so I know that they're in a different layer, so it's easier for me to calculate later that I need to do the parentheses first and then the cursive. So I have negative 1/3 times the cursive, which is 0, minus 1 minus 0 is 0, and 1 power, if your base is 1 to any exponential, you're going to get 1. So I'll simplify it, you will get 1/3. So that would be the final answer for number 12. All right, so that's it for this homework problem. Let me know if you have any questions.